Good morning to you once again. Last time we are looking at the Earth's interior. We looked at various things concerning the Earth's interior, whereby we talked about the internal structure as one of the structure of the Earth. We talked about various aspects in terms of layers, whereby we talked about the Sinai. We talked about the Sima. We went ahead and looked at also the mantle, where we talked about the upper mantle and also mentioned about the lower mantle. Then we moved on to what we call the core, where we talked about the outer core and the inner core as the layers that tend to be found within the Earth's interior or the internal structure of the Earth. We mentioned they were around 3 major layers, where we talked about the crust as having the Sinai and also the Sima. We moved on and looked at volcanism. We talked about the material that is ejected onto the Earth's surface and the material that tends to be piling within the Earth's interior, and which landforms that they form at the end. Today we are going to be picking up from another thing, and this one will be the types of volcanoes. Last time we talked about volcanism. This time round we are going to be looking at the types of volcanoes, and we look at them and how they are classified into. When you look at these types of volcanoes, they are classified into various ways, or their classification is based on model of eruption. In other words, the quantity, volumes of eruptions. We have what we call a type of eruption known as the erosive eruption type. For this erosive volcanic eruption, this one deals with eruption of lava. We can call them also volcanic dusts, talk about volcanic ashes, talk about fragmental materials. These ones move through what we call a narrow pipe or a small opening found within the Earth's crust. This is a narrow opening under the impact of volcanic or violent gases that tend to be moving down from the magma chamber onto the Earth's surface. So the material that tend to be passing through that piece is known as volcanic material, through what we have called the vein. Then you have what we have different types in there, or types that are being formed. We have what we call the Howin types of volcanoes. These Howin types of volcanoes, they are quite different compared to the Stardom types. These Stardom types, for them, they are known for being with moderate magma tending to be flowing at a moderate intensity, whereas the Howin types of magma, these ones are we call them they are viscous, or we can call them non-violent natural gases that tend to be moving within the Earth's interior, and these ones, they are not violent in nature. They flow with ease and they are not actually violent. When we move on, we are seeing the volcanic types also there, and we are going to be looking at the quiet eruption type. This quiet eruption type eruption along the fractions due to the weak gases and huge volumes of lava. So these ones, they tend to be flowing where we have lines of weakness, and they flow in huge volumes of lava. For instance, if you look at what you call lava flow, mud flow, or all these types of magma or lava, they tend to flow with weak gases, or they move at a slow pace. When you look at areas that are associated with the floodplains, you may be having different or several vents trying to originate from the Earth's interior onto the surface, but the material moves with a slow speed to occupy the surface. And then they are saying below there that the other can be classification according to the basis of periodicity of magma. When you look at this magma, it is given, or it is classified according to active volcanoes, dormant, and extinct volcanoes. When you move on, we have what we have termed as mechanism and the causes of volcanism. When you look at volcanism, is a process of it is referred to a process, whereas volcanoes are referred to the features. Now we are going to be seeing the spreading plates or margins and how they tend to be happening. We talk about where plates move away from each other and they separate or they divert from the margins due to volcanic eruption. Usually areas that are associated with the gentle extinctions will be leading to what we call the basaltic lava, or they will be bringing out the basaltic lava simply because of the way how they tend to be spreading. When we move on, we are going to be seeing most of these, how they occur under the water, where magma rises from the great depth before it fills up the space to create what we term as a seafloor spreading theory, or a sea spreading material that causes or that solidifies within a range or a rate of about 10 meters in a year. That is what we have termed as the spreading plates margins. And then you have what we call the subducting plate margins. These subducting margins, these ones look at one plate being subjected or pulled under a neighboring plate as they squeeze together. In addition, however, in addition to the old plates, we are going to be seeing that we have some plates that are going to be pulled, taking them to different places, and they will be causing the fracturing of the Earth's crust, bringing about a change in the crust, or causing depressions, or what we can term as hosts at the end. Now these volcanoes can form different cone shapes after eruption has taken place. When we move on, we are going to be seeing other process. Then we have what called the predicting eruption. This predicting eruption, volcanoes work in a way that anytime they may be experiencing eruption to take place, and this one results to procedures, signals that may be put in an area to detect or to predict, however, or it may sometime erupt. So they use what we call the predicting eruptions. There I've told you how they do it. They place predicting or detecting signals in order to detect when eruption will be taking place, to give people warning so that they are able to vacate those areas. When we move on, we are going to be seeing world distribution of volcanoes. How are these volcanoes distributed? And we see now, when you look at the volcanic belt, this is a geographical region which is very high, which with a very high levels of volcanic activities. In other words, this area associated with volcanicity, anytime they can be erupting. So when they erupt, they form different volcanoes or features at the end. They are saying that along the edges of tectonic plates, although there are internal plates, volcanoes that are formed from the mantle. Then they are saying yes that they have what we call hot spots. Igi, the Hawins, some of them. Then the other, they talk about areas like Iceland, where these volcanoes tend to be happening each and every time. I think for now we can stop here. Then we shall be picking up from there next time, where we shall be looking at the circular Pacific Belt Sea. Then we will also look at the mid-continental belts as the world distribution of volcanoes. For now, I beg to stop here, where we shall be picking up from next time.